very important, very germane in the sense that it's going to help you when you start your analysis journey. It's in a way going to guide you on the type of or the kind of analysis to do whenever you want to run an analysis. We just do descriptive analysis. What am I looking at? Why am I interested in descriptive analysis? Why am I looking for the mean? Why am I looking for the median? Why am I even doing t-test? Why am I doing logistic regression? Why am I doing regression? As a case may be. So in this class, in the next few minutes, I'll be able to, explain or, in a way, introduce us to why we do different types of analysis. And then I'll be using a journal as a case study or as my instrument to teach. Can we see my screen?
Yes,
Yes,
sir.
sir.
Oh, that's fantastic. So you can download this also from your end, or practically I will share with us or at the end of this class. This talks about selection of appropriate statistical methods for data analysis. The selection of appropriate statistical method for data analysis. We are not so much interested in the abstract. So I won't go through the introduction. I will just go through a table and I will explain what we have in the table. And when I share this material with us, we can do well to peruse through. Feel free to ask me questions if there is need to. Maybe you can come to my DM or practical. I think my email address is quite on the group. You can, do well. And then in our next class, we do a practical aspect, and then maybe I'll prepare a little slide too and do another introduction to this, or more like a concluded part of this class, and then we are good to go. Are we good with that?
Yes, sir.
All right. Okay. Practically, this is table 1. Table 1 has the parametric and the alternative non-parametric analysis to do. I will still explain what parametric and non-parametric methods are, actually, what I mean by parametric and non-parametric method to us in a few minutes. But if you check your left-hand side, you would see that you have the description. Okay, let me just go straight. We use parametric analysis when your data is it follows a specific distribution, that it is normally distributed. When it is not normally distributed, you quickly take into cognizance or you make use of non-parametric tests. For those that did statistics, you can do well to read a little about a normal distribution. There are characteristics of a distribution to be normal. It's not really in the scope of this class. Practically, this class is just a practical session analysis, so I won't be dwelling too much on theory, but for your own good, you can just take time to read about what do you mean by normal distribution. So practically, parametric methods, you make use of it when your distribution is normally distributed, or your data rather is normally distributed, and you do a non-parametric methods when your data is not normally distributed. So when do you do a descriptive statistics? If you remember in our first class, and I think in our last class, when we were playing around SPSS, we in a way touched descriptive statistics when you saw me doing frequency, percentage. An elder brother of frequency and percentage is just your mean and your standard deviation. Your mean and standard deviation is even more widely accepted than your frequency and percentage, because anybody can do frequency and percentage. But when your analysis is represented with mean and standard deviation, that's practically descriptive statistics. But if that is for a parametric, if it is not parametric, all you just do is just median. You find the median and then you find the interquartile range. What do I mean by interquartile range? That is the Q3, and then you subtract the Q1 from it. The third quartile and the first quartile, you find the range. Range is more like the difference between the third quartile and then the first quartile. That's what I mean by interquartile range. And then sample with population. I believe you can all see my screen, please.
Yes,
Yes,
sir.
sir.
Okay, please, I want to ensure that we are following. When we do a sample with population, we use of t-test. Most times, t-test is used when your sample size is small. You make use of t-test when your sample size is small. When you have a sample size that is less than 30, most times. But when your sample size is more than 30 or greater than equals 30, use z-test. And then when it is a data that is not normal, don't worry, in our next class or in another class, I will teach us if I will do well to remember to teach us how to know if my data is normally distributed. There are tests to actually know that, oh, my data is normally distributed. Oh, my data is not normally distributed, or my data follows a normal distribution, while my data do not follow a normal distribution. So when your sample has just is population, you make use of t-test, or a one sample with consign rank test. When you have two unpaired groups like this, you have two groups. Maybe you have a group A and then you are checking it with another group. Use of independent sample t-test, you call it unpaired. On the other hand, if it is a non-parametric, you make use of Mann-Whitney U-test or you consign rank test. These things are what we will do practically. I'm just introducing us to the theoretical aspect so that we can in a way have an idea when we start it. When we have two paired groups, or when you have two paired groups, you make use of paired sample t-tests. For the non-parametric you try then when you have two or three or more groups, there is what we call ANOVA. ANOVA is simply analysis of variance. We make use of ANOVA, analysis of variance. When you have three or more paired groups, you just use repeated measures ANOVA, and then the same non-parametric test follows. When you want to predict one outcome variable by at least one independent variable, what this means is that you have your outcome variable, and then you have another independent variable. You can also call your outcome variable a dependent variable, as I rightly said in our first class. If you haven't watched the video, is it first class or second class? Do well to watch those videos. It will help. And then it's what we are building on. We use a linear regression. When you have maybe y equals beta naught or bu plus b1x, your y is called your dependent variable or your outcome variable, while your x is called your independent variable or predictor. So you make use of a linear regression for such. When you now have multiple x, you can call it multiple linear regression. And then the other aspect you focus on is your non-parametric model for it to use a non-linear regression or log linear. These things are things we will practice. This is just an introduction so that we have an idea. Now, if you now want to compare, some says association, some might say you want to check the relationship. I think you can see here, test the association between two categorical variables. Use Pearson chi-square or use Fisher-Isaac test. Fisher-Isaac test is used when you have maybe the column is not less than 5 and then use Fisher-Isaac test. But when it is more, you use Pearson chi-square. You use it to check the association between two categorical variables. Two categorical variables in the sense that, let's say we have male or we have gender. Gender is male and female. Let's say we now have age group. Age group in the sense that 15 to 25, 26 to 39, 40 to something. Those are categorical variables. You cannot use t-test this time around. You will only use chi-square to check the association or the relationship between two categorical independent groups or categorical variables. Now, when you now want to test the change in their proportions between two or more groups, you use McNeman. When you now want to compare between the proportions, use z-test. And then this data type means that variable has two or more categories. Here, your variable has just two categories, and then your variable has two categories here. You can read the advantages and then disadvantages. One thing is that both has its own advantage, and then the other one too has its own disadvantage. So we can check through, and then I will share this material, then I'll go to this table again. My time is running fast because I have to, I'm so sorry, this class is going to be very short, please. Semi-parametric and non-parametric tests. Now, this table 3 says, if you want to predict the outcome variable using independent variables, use a binary logistics regression. The data type is you have outcome variable, two categories. The outcome variable, as I rightly said, is your dependent variable. You have two categories. Let's say you are interested in hypertension. Is that someone is hypertensive or the person is not hypertensive. So when you have the case of hypertension, is that a yes or a no? So that means such a variable is a categorical variable, and then you can make use of binary logistics regression in this case. And then when you have different independent variables, the independent variable can either be categorical or continuous. As it is stated here, a categorical variable, two categorical variables, or continuous variables. You have a better understanding of some of the things when we do the practical. This might just look like, what is this man saying now? But by the time we begin the practical aspect of this class, you'll be able to see, oh, how does my outcome variable looks like this? How does my independent variable looks like with categories? How does my independent variable that is continuous looks like? By the time we begin to do hands-on training or practical. Now, when you want to predict the outcome variable using independent variables, you can use a multilinear logistics regression. When you use multilinear, it means that your outcome variable has more than 3 categories. Let's say, for instance, that you're using a Likert scale. You have strongly agree, disagree, neutral. Such has more than 2 categories. Such start from 3 categories or more, use of multinomial. Or let's say, for instance, now you want to measure your outcome variable is maybe it has to do with mental illness or mental impairment, or I don't know if I'm speaking the right word right now. They will say that mentally stable, different categories of it. And something I did a work some years back on it. Recent times I've not done. They will say, I think, is it stably impaired, normally impaired, all those different categories. You have more than 2, and then it starts from 3 and above. So in that case, you use a multinomial and logistics regression or paraventure, or for instance, let's say you have your BMI. I think sometimes some categorize BMI into 4 categories. Some will say underweight, some will say normal weight, some will say overweight, and then some will say obese. In such a case, you have more than 2 categories already. What can work for you if that BMI is your outcome variable is to use multinomial logistics regression. Are we following, please?
Yes, sir.
Oh, thank you very much. So if you want to check area under the curve, there's something we call ROC. If you now want to predict the survival probability of subjects for a given interval, let's say, for instance, you have people with stroke in a facility. What I mean by facility in hospital is that people with stroke tends to go to the hospital time over time, and then there is a kind of follow-up in between. In that case, you can check their survival probability. You can check if peradventure they are going to survive or not. So you make use of survival analysis, and that has with follow-up over time, more like a longitudinal data, or you can make use of a survival analysis. Now, if I want to compare the survival time, it's still under survival analysis too. You make use of your Kaplan-Meier curve. This also is still under survival analysis. You make use of cost regression. And then if you now want to, there are different tests, especially in medical line or medical field, when you want to do a kind of diagnostic check. You can check your sensitivity, you can check your specificity, and then some other, ones which we can make use of. I intend to end this class unfailingly by 7:30, and then in our next class, we do practical section. So, and then we also have a correlation analysis too. And then one thing is very crucial. Your correlation does not imply causality. If there is a correlation, that doesn't mean that correlation is a cause of that thing. If there's correlation, it doesn't imply causality. So these are some of the different types of analysis we'll be looking at. And then in the next class, I would have prepared a slide. I will show us different types of variables, and then in such a way that we'll be able to follow, and then we'll also have a practical data that we'll work with. But this is just more like an eye-opener to see what we'll be doing. And then I, as a person that is very committed, I don't want it to be like we won't have a class today. I could have just come to the group and say, oh, sorry, we meet so time. No. I don't want to do all that. I want us to, be faithful to it and to. So that is that. I think with this, I'm going to end this class. I will share this with you, and then in our next class, we'll do this proper. I don't know if someone has a clarification or a question before we call it a day. Over. Are you with me? Do you have a question, clarification?
Yes, yes, sir. Thank you, sir.
You're
Thanks for
welcome,
the
sir.
short thanks for the short presentation, sir. Actually,
Yes,
I must be sincere. Most of this thing is still coming as if you are so maybe when we get to the practical aspects per se, then we'll be able to like, at least pick the important aspects of it. So, but we really appreciate the little introduction you've done to the presentation, sir.
It's all right. It's all right. You're welcome, sir. You're welcome, sir. Okay. Any other question?
Yeah, thank you, sir. Sir, please, I just wanted to point out, sir, please, the last class that we did, that you did something about assessing knowledge on
Okay.
sexual violence or something like that.
Yeah,
So,
yes, sir.
I don't know. Like, I'm trying to look for a kind of file or something like that, or data that I can use to assess that. I don't know if you can share that particular part with us, or any data at all that we can use in assessing
okay.
that part.
It's okay. Well, be rest assured. We are still going to have a practical section as far as all those things are concerned. Those are practically, a way to introduce us to it. The issue of data sharing policy, data security is what is really giving me a concern. But I will go to GitHub or all these repository online, and we'll get a practical data we can work with. It could be an NGHS data too. I don't know if that is okay with us, and then we'll do some of these things, and then you'll see the way it actually works, in real life scenario. Is that okay?
Okay, sir. Thank you.
You're welcome, Dr. Awal, if I'm correct.
Yes, sir.
Okay, in the absence of any other question, should we can we call it a day?
Thank you, sir.
All right. I know some will still want to join. They will be shocked that the class has ended. All right, thank you so much.
Thank you very much, sir, for your time.
And do enjoy
We
the
really
rest of.
appreciate your time.
You're welcome. You're welcome. You're welcome. You're welcome.